Hi there, welcome back to another mathematical tutorial video. Today we are going to be learning about exponents and the rules of exponents. Now if you remember from our order operations video, an exponent means an expression in exponential form. So then you have to ask yourself, well, what is exponential form? Exponential form means a base raised to a power. So in this example, the letter A raised to the power of n. And just in case you forgot, A is the base and n is the power, also known as the exponent. Okay, so we have a base raised to a power, or a base raised to an exponent, so a to the power of n. And if we were to expand this out, this would be a times a times a times a dot 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 n dot dot dot. Okay, so what does this here tell me? This here tells me that I am taking a, multiplying it n number of times. Now, you can really go out to infinity here, alright? So, a to the power n might be known as an infinite set of objects. So, now that we know what an exponent is, let's look at some rules of exponents, okay? So, sorry, I have paper over here that's in my way. So let's look at the first power is going to be called the product rule of exponents. Some people might call it the product rule of powers. But basically, the product rule of exponents means this: a to the power n multiplied by a to the power m. Okay? And what the product rule of exponents allows you as the mathematician to do is this: a n added to m. Okay? So let's look at an example of this. And I should change this to rule number 1. So an example of this rule would be, sorry, not a, would be 2 raised to the power of 2, or 2 squared, times 2 raised to the power of 3, or 2 cubed. And what we get is, if we have the same base, notice how we have the same base with which is 2. Same base. If we have the same base, slide the base over, so that becomes the new base of the new exponent, okay? Now what do you do? So the product rule of power says that we can add the two exponents together as long as the base is the same. So we have 2 squared, or 2 raised to the power of 2, multiplied by 2 cubed, or 2 raised to the power of 3. Now remember from our PEMDAS video, 2 squared means 2 times 2, plus 2 cubed means 2 times 2 times 2. This does not mean 2 times 3, which is 6. So you have 2 times 2, which is 4. 2 times 2 is 4 times 2, which is 8 times 4. That's how you would normally do it, right? That is not what you're doing. What you are going to do instead have a feeling this whiteboard is going to fall over any second. So let me bring it back down. So what you are doing is you are adding the exponents, the power side. So 2 raised to the power 2 plus 3 equals 2 raised to the power of 5. This is your new exponent, and in many cases, this is all you have to do. This is your answer, 2 raised to the power of 5. That is your new exponent from this. Some situations you will have to expand or evaluate. 2 raised to the power of 5 is going to be 32. If you want to know how I got 32, while 2 raised to the power of 5 means 2 times 2 times 2 times 2 times 2. 2 and 2 is 4. 4 and 2, you get 16 and 2, which is 32. Alright, so most situations, all you have to do is write the new exponent from the original set of exponents. These are called a set of exponents. 2 squared, or 2 raised to the power 2, multiply 2 cubed, or 2 raised to the power 3. You slide over the base, you add the exponents, you get 2 raised to the power 5. That's your answer. If your homework or whatever you are working on says to evaluate or expand the new exponent, then you need to evaluate and expand it to get a new answer of 32. But like I said, most of the time, all you have to do is write the new exponent. Okay, so with that being said, let me erase this as quick as possible here. Okay, I don't know why I erased that up there. Let me find my green marker here. A n plus m. Okay, so let's say I have, what can I do as a new example? Let's say I have, and again, it only works with the same base. I will show you what you have to do if you have different bases in a second. But let's say I have 5 squared, 5 raised to the power 2, multiplied by 5 to the power of 4. Okay, so you have the same base, so you will slide the base over, so that's going to be the base of your new exponent, and then you do the power of 2 plus the power of 4 to get the base, which is 5, raised to the power 6. And this is your new exponent. Again, if your homework or whatever you're working on says to expand or evaluate the new exponent, then you need to evaluate the new exponent, which would take some time. With the bigger the power is, the more you need to multiply the base by itself. So 5 to the power of 6, that's going to be a really large number. If you wanted to do that, feel free and do it, but we're not going to do it on this video. So let me try another example then, okay? We have examples for days. Let's do 10 raised to the power of 2 times 10 raised to the power of 2. Let's do same powers. Okay, so again, the base is the same. Slide over the base. So 10 is going to be the base of your new exponent. Then you add the powers together. So 2 plus 2. So you get a base of 10 raised to a power of 4. And that is your new exponent. Real quick, another example. Let's do a to the 7th times a to the 10th. So we got a base of a raised to the power 7 plus 10. Base a raised to the power of 17. That is your new answer, a to the 17th power. Okay, so that is if, so this rule, a to the n multiplied by a to the m to the a raised to the power n plus m, this only works if you have the same base. Notice in all these examples, 5 squared times 5 to the 4th, 10 squared times 10 squared, a seventh times a to the 10th, we all have the same base, which is 5, 10, or the letter a. This is the only way the product rule of powers will work, if the base is the same. Real quick, let's look at if the bases are different. Okay, so let's say we have the exponent 2, come on, don't die out on me yet. 2 raised to the power 2, so 2 squared times, let's say, 3 raised to the power of 2. We do not have the same base, therefore we need to evaluate or expand each one. So this is 2 times 2. Okay, 2 raised to the power 2 is 2 times itself, 2 times 2. This is 3 times 3, not 3 times 2. So we get 2 times 2, which is 4. 3 times 3, which is 9. 4 times 9 is 36, right? Okay, so that is the new answer. We do not have an exponent, no exponent. So we just leave it as 36, okay? Let's try a new example then. Let's do, taking the letter a here, sorry about that. Let's do a squared times b squared, while a times a times b times b. You can't do a times b, okay? So a and a is a squared times b squared, okay? So again, rule number 1, the product rule of exponents, or the product rule of powers, only applies if the bases are the same. If the bases are different, you need to evaluate each exponent, and then you can find the new product. So that's what we did. And the previous example, we did 2 squared times 2 squared, which would be 2 slide over the base, so we get a new base of 2, then we added the 2 powers to get a new power of 4. So the new exponent was 2 raised to the power of 4. That is the right answer when dealing with rule number 1, the product rule of exponents. Now if we have a problem like this, 2 squared, or 2 raised to the power 2, multiplied by 3 squared, or 3 raised to the power 2, you can't do 2 times 3 and then 2 plus 2. You will end up with 6 raised to the power 4. That's not how you do it. You have to expand or evaluate each exponent. So you expand the first exponent with 2 raised to the power 2 to get a product of 4. Then you expand 3 raised to the power 2, which is 3 times 3, to get a product of 9. Then you multiply 4 times 9 to get a new product of 36. The same thing here. You have a squared times b squared. You can multiply a times b to get 2ab, and then 2 plus 2 is 4, so we end up with a new exponent of 2ab to the 4th power. That is not the right way to do it. You have to do a squared, evaluate a squared, which is a times a, evaluate b squared, which is b times b. So now you get, this is your answer, a squared times b squared, and you're done with this example. Alright, so that's rule number 1, the product rule of exponents. Let's look at rule number 2, and again, I'm just writing it however, and I'm gonna see if I can do 2 things at once. without screen up here. Actually what we will do, it's already 15 minutes, so watch the other video, which will be rule number 2.